Okay, good afternoon, everyone. So today we're going to continue talking about JavaScript functions and control flow, and also some array methods. So I would like to begin with some advanced control flow functions or advanced control flow operators, if you wish. Okay, and I would like to begin with ternary operator. So I'm just going to write it down here. Ternary operator. So ternary operator is another way of writing down your function based on true-false values. So it's going to be a conditional function. So let us write it down. So we're going to say is user valid? We're going to check it. So it's going to be Boolean. It's going to be Boolean like this. And I'm going to say return bool. Okay, and that's not very good to write it like this, so I'm going to say something like this. Okay, so that was one of the ways of writing our arrow functions, right? So we have, let's say, a function name, then we have parameters, and then we return something at the end. So here we're just returning the same parameter that we input. Sorry. But what if for true values, I would like to return something else, and for false values, I would like to return something different as well. So let us check the following. So I'm going to write down a variable. I'm going to say answer. And here I'm going to do the following. I'm going to say is user valid. I'm going to say true. And now look at this syntax. So this is the syntax that I would like to show you today, and this is what we call a ternary operator. So we have our function, okay, and we input true. So what happens if we have our condition true here? Well, it's going to check this function, and if the condition is true, it's going to return this one, the first value, which is welcome sir. And if this is false, everything you see after the columns are going to be returned. So here is going to return access denied. So if we will print out answer, it will give us welcome sir. Okay, and if we change it to false here, it will return us not welcome sir. It will return us access denied. And we can have a look even. Okay, so let me run it. So in the browsers, I'm just going to connect my script. Okay, so now let me run it. One moment. Okay, so it's our index.html. So index.html, and one moment, please. So in my code, I have it. Well, let's check what is the answer. Answer says access denied. Why is that? Because our condition is actually false, and that's why it returns the second value. If it would have been true here, and we refresh it, it returns welcome, sir. So that's what we call a ternary operator. It's just another way of writing down your function, okay? And well, it's not really necessary to write down your functions always like this, but if you see it in someone else's code, so you won't be confused. Is that what we call ternary operator? And it's just good to know, okay? And I honestly and personally, I prefer to use arrow functions instead of even ternary operators, but it's very common to see people writing something like this. So don't be confused if you see one. And moving on, and we are going to talk about switch operator. And many of you know switch from Java. Many of you even implemented it in their homework. So let us see what is switch advanced control flow. So I'm going to use switch here. And well, let's do the following. So I'm just going to write a function, or let me write it even like this, move command. And I'm going to say direction and var, oh, let's say let result. I'm going to use switch. Switch is a keyword. It allows us to switch between different between different conditions here in this between different input. So I'm just going to say switch, and what is going to switch is our direction. And look at the syntax. I'm saying switch, and then inside of my parentheses, I say my input value, direction, and then in curly brackets, this is what I'm going to write. So I'm going to write different cases, and the first case is going to be forward. I'm just going to say forward. And in case of forward, result will be, well, let's say moving forward. And then you break it here. Then you write the second case. And the second case, let's say backward. The result will be moving back, one, break. So we are breaking from this condition. Then the case will be left. We will say result moving left, one, break. And finally, case right, result moving right, one, break. And there should be also a default value. So we're going to say default, and default is going to be result valid direction, or invalid direction, we can say. Let's say just valid for now. So we're expecting valid direction either forward or backward, left or right. And then we return result from this operation or from this function. And now let us run this command. So this is how my function now looks like. Okay, I have a function, arrow function, that accepts value direction. Okay, and then I'm creating a variable result, and then I'm using a switch operator that says switch, and it accepts value direction. So if it's case forward, the result will be moving forward one. If it's case backward, moving back one. So it's also the same as if and if then else. Okay, so if case or if direction forward, moving forward one. If direction backward, moving back one. If direction left, moving left one, and if direction right, moving right one. So it's the same as if and else operator. There is only one significant difference, is that this is a little bit different syntax. Okay, and let us see how it's going to work in our case. So I'm going to share the screen with you, and let's see. So I'm going to say move command, and if I say left, it will say moving left one. If I say right, it will say moving right one. Then backward, moving back one. And if I say just back, it will say valid direction. So it expects us to put something between those 4 values, either left, right, backward, or forward. So I'm just going to say forward here, and it will say moving forward 1. So this is the switch operator, and you know it from Java lessons. It's just for you to remember, just to remind you that we also have it in JavaScript. It's not that difficult, okay? So it's just another way of writing your if and then conditions, okay? And this is how we implement it, okay? So we write switch keyword, and then we expect some input, and the input, in case of input forward, result will be something. In case of direction backwards, the result will be something else, and so on and so forth. So forth. And we also have a default, so it means that if neither of these one is satisfied, we will return invalid direction, or let's put invalid direction even. Okay. So we are saying that neither of these one is satisfied, so this is else basically. Okay. So we are expecting to do something else here. And that's a little bit about switch. Okay. And it's good to know. It's just another way of implementing, once again, if else conditions. Okay, so now we are going to talk about advanced functions, and I would like to introduce you to advanced closures, or closures is just a way of say functions as the variables. So every time we call the functions, it comes from memory, okay? And so let me even show you. So I'm just going to continue here, closures. Okay, so let's say we have a function that multiply, okay, and multiply accepts 2 parameters. A by default is going to be 2, and B by default is also going to be 2, and then it returns A multiplied by B. Okay, so what happens is that if we run this command, okay, without any values, without any input, it will return us 4, right? So at the end, if we will write something like let 4 be multiplied, okay, we will have 4 is equal to 4 as a number, okay? And closures is just another way of saving memory and saving yes, just saving memory. So for example, if we will need 4 every time we call, we are going to call this function, it will always run it again and again, and it will spend, well, a lot of memory, let's say. Instead, what we can do, we can actually save the result of this function in the variable, so that every time we need it, we simply can recall it from the memory using variable. So instead of calling this multiply again and again and again, we can simply say 4 instead of multiply. So for example, let's say we will later on need to calculate, I don't know, B, and B is actually multiply and then by 2, okay? So instead of calling multiply once again, we can simply say 4. We can simply say 4 multiplied by 2, okay? And 4 contains the value that we get from this function. And this function is actually returns as 4. So it means 4 multiplied by 2, and B is going to be equal 8. And let's say C is also 4 multiplied by 3, so it's going to be 12, and so on and so forth. Okay, so instead of calling multiply every time we need to get 4, we're just using well, let's say A instead of 4. So it's going to be a little bit confusing, so we're going to say A. So A now contains the result of function multiply, which is 4. So every time we need 4, we're just going to say A. Okay, and it's called closures. So every time we need the result from the function, we probably need to save it once, and every time we call it somewhere, we just need to recall this variable. Next thing I would like to introduce is currying. Okay, And currying is an advanced technique of working with functions. Okay, it is used not only in JavaScript but in other languages as well. Okay, currying is a transformation of functions that translates a function from callable. So we are going to say f as a function. Okay, f is a function, and then we say a, b, c. So our function accepts 3 parameters, and currying is just a technique. Instead of accepting 3 parameters at once, we are going to accept it separately like this: a, b, and c. So currying doesn't call a function; it just transforms it. So let's use multiply, and I'm going to show you how we can do it. Okay. So multiply here is just a multiplied by b. So I'm going to say like this, right? So we have a multiplied by b. What we can do is that we can turn it into curried multiply. We can say curried multiply is going to look like this: a, b, then a multiplied by b, or return a multiplied by b. Okay. And this is what we call curried multiply. Okay. Like this. So what we are going to do now is we are going to use it. So let me show it how it's going to work in our browser. So okay. So if we're going to say multiply, and then we say 2 by 2, oh, let's say 3 and 3, is going to return us 9. What is curried multiply? Curried multiply is another way of writing your function, but instead you break it down into 2 separate functions. Okay, so we can say curried multiply, and then it accepts 2 values. The first one is going to be 3. So if we save it like this, okay, it says none, so it's not a number. So it accepts another parameter, which is also going to be 3. One moment, please. Curried multiply. Everything looks fine. Oh, yes, sorry, here. Should be like this. So now let us run it one more time. Okay. So multiply, we run it, we need to provide 2 input values. With the curried multiply, we can provide only 1 value. So if we provide 1 value, it says it expects the second input. So we can say curried multiply 3 and 3 is going to give us 9. So you may think, oh, it doesn't make any sense. Well, it makes sense if we use variables. So let's say a is going to be equal curried multiply 3. So then if I say a and 3, or let b is going to be a and 5. So what do you think b is going to be equal to? B is actually equal to 15. Why? Because first, a is actually contains the first part of our function, which is which we provide as 3. So caret multiply 3 here, okay? It is what A has, sorry. And then B is the second part. So this one doesn't exist anymore. So it's here A, okay? And all we need to do, we need to provide B. And B is going to be, in our case, 5. So, well, it's a bit confusing because I'm using the same variable names. So let it be number 1 or number 2. Okay, so number 2 is going to be equal to 15 because our A contains the first part of the function, and all we have to do is provide the second part, second input, which is in our case 5. So 3 multiplied by 5 is going to be equal 15. So that's what we call currying in JavaScript. And I know it's a little bit confusing principle, it's a little bit a confusing technique, but it's used in many cases. For example, when we have repetitive first part of the functions in many in many lines of code. So instead of calling it again and again and again, you can save it as a variable and call this variable with different parameters on the second part. So if your B is going to change all the time, let's say like in multiplication table. So in multiplication table, you remember, right? So you start 1 multiplied by 1, and then you have 1 multiplied by 2, and so on. So you can see the first part never changes, but only the second part changes. So instead of calling the same function and again and again and again, so here you will provide 2 input values. So what you can do is actually you can save the first part as a variable. So let's call it num1 or anything, okay? And all you have to do is just change the second part, which is going to be increments value from 1 to 9. So it's going to be 1, 2, 3, 4, 5, and until 9. So we can even implement it here if you wish. So we're going to say let 1 to be a, oh, not 1. 1 is not a good example. Let's say 2. This, oops, sorry, not a, but caret multiply, and we're going to say 2, like this. Then all you have to do is you just need to recreate multiplication table. So you're going to say 2, 1 will give you 2, 2, 2 will give you 4, 2, 3 is going to give you 6, and so on. So it's actually going to look like a multiplication table that we all know, that we all seen on the back of our notebooks, right, when we studied at school. So it's just another way of breaking down your function. So the first part is going to be saved and called from the memory. Only the second part is going to change, okay? So it's another way of saving your memory and making your code look more clean. Moving on, I would like to talk about composition and decomposition, okay? And compose and function composition is a technique or mechanism of combining multiple simple functions to build a more complicated one. And the result of each function is passed to the next one. And in mathematics, it's wrote something like this. I'm just going to say here, composition. And in mathematics, if you have two simple functions, let's say fx and let's say gx, okay, two simple functions, okay? So composition is actually going to look like this. So this one. So the result of the second function, which is gx, is going to be passed as an input to function fx. And if it doesn't make sense right now, let me just simply implement it so you will see that composition and decomposition is not that hard, okay? So let's say we will have two functions, const add, and it's going to accept two value a and b, and it's going to return us a plus b. And we will have another function, which is multiplication or multiply. We already have it, so we don't need it anymore. So what do you think will be a function decomposition? Or sorry, composition. Function composition looks like this. So we have a function add, and it accepts two parameters, A and B. A, we are going to say, well, let it be 5. And B is actually going to be result of another function, multiply. So we're going to say multiply. And here we're going to say 3 and 4. So what will be the results? What do you think, guys? I just want you to check it. I don't want to display it in the browser because this one is quite easy to understand. What will be the result of this function? Anyone? Olivia?
I think it's going to be 5 plus 3 times 4. So it's 17, I think.
Right. So we first multiply what we have inside of it. So you can see add is kind of a parent function. Okay. So we start compositioning, or we start getting results from the inside of our parentheses. So we first multiply 3 by 3 by 4. It gives us 12. Okay. And then we say 5 and 12, which is actually going to give us 17. Okay. So we sum up only after we get the results of this function. Okay. And that's what we call composition. And function decomposition is the same thing, but vice versa. So we instead of making one complicated function, we break it down into small functions. So if you have something like f, g, x, and then let's say m, x, okay? So this is a very complicated function. You can break it down into something like f, x, and gx, and mx, okay? But mx is going to be evaluated first, and then it's going to be passed to gx, and then it's going to be passed to fx, okay? So let's say we have a complicated function like this, okay? So to decompose it, what we are going to do, we are going to calculate 2 and 2, okay? And we're going to save it, let's say a. So a is going to be add 2 and 2, so it's going to be equal 4, right? And then b is going to be multiply 3, and then we say a. Okay, so what is going to be our results will be 12. And then c is actually add, here we have 5, and the second parameter is actually b. So once again, it will give us 17. Okay. So this function is a function composition, so it's a very complicated function. We break it down. We use function decomposition to first calculate our first input, which is add 2 and 2. So we just say we just take a and b and we sum them up. It will give us 4, and then we pass that result, pass that variable as an input to the second function, which is multiply. Multiply 3 multiplied by a, which is 4. So 3 multiplied by 4 gives us 12. Okay. And then we take that 12 as a b, and we pass it to the last function, which is add 5 and b. And it, at the end will give us 13. Yeah, I will check. I will send it a little bit later. Okay. So that's what we do, and that's what we call function composition and function decomposition. Okay, and you probably need to you probably need to understand these techniques and mechanisms, because that's what I want to see in your assignment number 4. Assignment number 4 will be this week once again, and it will consist of many things like composition, carrying, and closures probably, and other advanced techniques. Okay, so you will do the same task. So you will once again build the same calculator, but instead of writing it with if functions, instead of writing it with other instead of writing it with old version of JavaScript where you used var, you're going to do everything with what we have learned this week. So it's going to be ES6 syntax. It's also going to be different techniques and different methods. Okay, what kind of methods? Let me introduce you to now. Okay, so advanced array methods consists of many methods, and the first one I would like to introduce you is for each. And we already know for each, right? So the for each method calls a function once for each element in an array in order, okay? So the function is not executed for array without elements, okay? So let's say we have a array fruits, and then we have different types of fruits. Let's say apple, orange, banana, a cherry. So we have we have four fruits here, okay? And cherry, you can say it's a berry, but anyway, it's a fruit, right? And we're going to use for each method, we're going to say fruits. So here is the syntax is that we use the array, name, which is fruits, and then we say for each, for each, and inside of it, we are going to use my function. I'm just going to say my function. You may be wondering, what is my function? My function is what we write here. So we are going to write it separately. We're going to say my function is going to accept item. And well, let's just simply display it. So we're going to say console log. And we're using ES6 template strings. So we're going to say this is item. Okay. What do you think is going to be displayed here? I'm going to comment this out so you won't be confused. Let us see what we are going to see. Okay. Cannot access my function before initialization. The orders matter in this case. So we first need to define the function and only then we need to call it. Okay. And as you can see, for each works is that we call this function for each item or for each element in our array. And each element is actually apple, orange, banana, and cherry. So every time we call it to each element is going to take this element and display it with the text. This is item, this is apple, orange, banana, cherry. Okay. So that's how for each works. Okay. So we may modify our values with this one, but it's better to use another method which is more suitable for this type of work. Okay. And we're going to talk about advanced functions after the break. Okay, so let's have 10 minutes break. But before you go, let me share the password with you so you can mark your attendance. I've just sent you password, so please mark yourself. Okay, let us come back at 3:50. Okay, so it's going to be 13 minutes break. So let us continue. And I'm going to share the screen. So the next method that I would like to introduce you today is called map. Okay, and the map method creates a new array with the results of calling a function for every array element. Okay, and the map method calls the provided function once for each element in an array in order. Okay, so let us see how it works without further details in theory. So just to tell you that this method does not change the original array. So this is what we are going to have. Okay, so we have fruits, apple, orange, banana, and cherry. What we're going to do is actually we are going to create a new array from map, and we are going to say fruits map, and so map, and we're going to say item, return item plus, or let's use simplest literal. So we're going to say this is, sorry, where's this one? Okay, this is fruit, and we're going to place an exclamation mark. Okay, so we're going to save it now, and let's see how it's going to look like in our browser. I'm refreshing it, and you can see this is apple, orange, banana, and cherry, and this is the result of previously calling for each. I'm going to comment this out. Okay, so we're not getting anything, so everything is correct. So now, since we just created the new array, okay, when we use the map method, okay, once again, map method creates a new array where we apply a function to each element of the current array. So the current array is fruits, and the new array is called new array map. So let's compare them. I'm going to say fruits, and fruits are apple, orange, banana, and cherry. So there is no much difference between what we have here and in the initial value. So there are no changes in the initial array, but let's see new array map. A new array map actually shows us that there were changes. Okay, so it's to each element of the previous array, we added a text, which is this is, and then an exclamation mark at the end of each text. So this is apple, this is orange, this is banana, this is cherry, and so we apply map to each element of our initial array and we return it as a new array. And to make things more understandable, we are going to create a new one. Let's call it just simply array, and we will have numbers here, 1, 2, 4, and let's place 8 here. So, and we are going to apply a map method to this array, and we're going to save it to new array or new list, just call it like this. Okay. So what do you think will be the results if we apply a map to each item? And we're going to return square root, or not square root, squared numbers. So we're going to return item multiplied by item, right, basically. What do you think will be the results? So we're going to save it and refresh it here. Our list is just the numbers 1, 2, 8, 1, 2, 4, and 8. And our new list is actually all these numbers in squared numbers. So 1, 1, 2, 4, 4, 16, and 8, 64. So as you can see, we use the array map method to apply some function to each element of our original array and return it as a new array. Okay, so very useful method, and you probably going to use it in your assignment number 4. So try to understand it properly and play around with this method. So moving forward, we're going to talk about next method, which is actually filter. And let me show you. So filter, and this one was map. Okay, so we have for each, we have map, we have filter. So let's talk about filter. The filter method creates an array filled with all array elements that pass a test. So basically, if there is a condition satisfied, we return it. So let's have a look. So we are going to use the same array list of 1, 2, 4, and 8. And we are going to use the array method filter to create a new array. So we're going to say const new list filter. We're going to say list filter. And the syntax is the same, as you may see. And we're going to return item, which is divided by 2, has no remainder. Okay, so this is actually our condition here. So our condition is that if we divide our item by 2, it will not have a remainder. So if we when we run this function on or when we run this method on our list, which is consists of 1, 2, 4, and 8, what do you think will be the results of new list filter? Let's have a look. Look, so our list is actually 1, 2, 4, and 8. And as you may remember, our new list, we used map. So new list is going to be 1, 4, 16, and 46. What is going to be numbers or what will be the values in our new list filter? Let's have a look. New list filter, as you may see, has less or fewer numbers, fewer values. So here we have 4 values. So the length of this array is 4, and the length of this array is 3. So we have 2, 4, and 8. Why is that? Why we don't have 1? We don't have 1 because it doesn't satisfy this condition. So 1 divided by 2 is 1.5, which is not actually a remainder that we are looking for. We are looking for remainder 0. So for example, 2 divided by 2 gives us a 1, so the remainder is 0. 4 divided by 2 gives us 2, so the remainder is also once again 0. We don't have a remainder here. And 8 divided by 2 has no remainder as well. So that's why these 3 values, that's what we get in our new list filter. So the difference between this map method and the filter method is that in the filter method, we always execute some kind of a condition, so some kind of a test. So we do conditions, or we do tests with our values of the original array. Okay. Here we just we do different operations. Here it must be a condition so that it should be satisfied. So if we will let's say we will apply it not to list filter, but let's apply it to new list. What do you think will be the results? Let's check. Let's have a look. New list is actually 1, 4, 16, and 46. What do you think will be new list filter? It also removes 1 because 1 is has a remainder and other value has no remainders. Okay, so that's why we get 4, 16, and 46. Okay, so that's how we use filter methods. Okay, and filter and reduce methods are going to be used in your assignment number 4. So the last method that I would like to introduce you today is called reduce. Okay, and let me show you how it works. Okay, and the reduce methods, it actually reduces the array to a single value. So that's why it calls reduce. Okay, and the reduce method executes a provided function for each value of the array from left to right. So it takes each value from the array, from this one to this one, for example. And the return value of the execution is stored in an accumulator or result or total. Okay, so let us see how we can execute it. So reduce. So we're going to say const new array or new list reduce, and let's execute it. So we're going to say array reduce, and the function is going to accept 2 values, accumulator, or let's call it simply result, and item. Then we are going to do the following. We are going to say return result plus item. Result and plus item. And I put 0 here. This. That's how it should work, as long as I remember. So reduce was one of the functions that, or one of the methods that actually drove me crazy. It's a little bit complicated even to understand like this. So let me go to Google. One moment, please. One moment, please. Okay. Let's see how it's going to work with this one. So what do you think will be the result of new list reduce? Okay, if we apply reduce method to the array, not array, sorry, it should be list here. Yes, 1, 2, 4, and 8. So let's check what will be the results of this function or of this method. So list is 1, 2, 4, 8, and new list reduce gives us 15. Why is that? Because it simply takes each value and accumulates it together. So basically it takes result by default is 0. Okay, so we are going to say 0 plus item, and item in this case is this value, so 1. It says 0 plus 1 gives us 1, so the result becomes an accumulator, so it accumulates value, and it becomes 1. So we move on and we come to the second value. So we say 1 and item is actually 2. So 1 plus 2 gives us 3 and the result becomes 3. 3 and the next item is actually 4. So 3 plus 4 gives us 7. And lastly, 7 plus 8 gives us 15. So that's how we implement a reduce function. So it basically reduces our array to a single value. So it's not even a list anymore. It's just a single variable that says 15 or that says something. Okay, and we can actually change the initial value of our accumulator. So if you want, you can change the result. So it wouldn't be 0 by default. By default 0 now, but we can change it. So we may say something like this, if I'm not mistaken. Where is it? Yes, it should be here. So we first use getSum. So this is our function. Let me write it separately so I may track down where I should put it. So my reduce function result item going to return result plus item. Okay, so I may write reduce function and change the initial value or change the result in my case. So the initial value by default is actually 0. So I'm not going to change it to 0. I'm going to say it's 5. So what do you think will be the result of this method? Sorry. Oh, it's fine. So what do you think will be the results of this method? The result will be actually 20. Why? Previously it was 15, but now, but remember, previously our initial value, our result value was by default 0, but now we set it to be 5. So it starts not from 0, but 5. So we are going to say 5. An item, the first item is actually 1. So it says 5 plus 1 gives us 6. And then 6 plus 2 gives us 8. 8 plus 2 gives us 12. Not by 2, but by 4. Of 8 plus 4 gives us 12, and then finally 12 plus 8 gives us 20. So we may change it to 10, and the result of new list reduce will be 25. So the initial value plays a huge role here. So whether it's going to be 0 by default or whether it's going to be something that you set, okay? And reduce and other methods like map and filter, they actually can be used together. So for example, we can use filter to remove some unnecessary values that do not satisfy our condition, and then we can reduce that array to a single value that we need. Okay, and your assignment number 4, I will actually put a condition or put a must-have item. You will have to implement array reduce together. But to make things more easier for you, I'm going to share an example how you can do it. Okay, so don't worry about this one. So just for you to probably, all you have to do is to look at the example and try to understand that example and implement it in your own assignment. Okay. And that's probably it for this part. Okay, so once again we talked about different functions and methods, and also we talked about advanced control flow operators like ternary operator and switch. Okay, and once again, ternary operator is widely used, it's commonly used, but I personally don't like it. So if you see something like this, don't be confused, don't be scared, okay? It's just another way of implementing your function with conditions, okay? And switch is, I think it's more popular than ternary operator. Some of you even done it for your assignment number 3. So that's great, but switch is probably better to place it like it's no different from if else operator. It's just a different syntax, but the logic is the same. And then talking about advanced functions, so we have closures. Once again, we use closures is to save memory. So basically, if you're using the same function again and again and again, I mean, the result of the the same function, you probably need to save it as a variable and then call it whenever you need it. Currying is a technique or a mechanism of breaking down your function into 3 consecutive functions. So in our case, we broke our function multiply into carried multiply, where we save our first the result of our first part as a variable, and then we just change the second part, which is b. Okay, so a in our case stays the same for 9 operations. In case of multiple table, we only change the second part. Okay. And we also have function composition and decomposition. So once again, composition is when you have simple functions and you make a complicated one by just putting it together. And decomposition is vice versa, when you have a complicated function and you break it down into small functions, very simple one. And then we have 4 advanced methods, array methods for each, which is actually iterates through each element of an array and does something with this one, but it doesn't change the original array. Then we have map, and map is used to the same as for each, but it does return a new array with modified values. Filter, we use the same as map, but here instead of just returning something, we need to return values that satisfies a certain condition. So that's why it's called filter. And finally, we have reduce, that actually reduces our array into a single value. Okay, that's what I want to introduce you to this week. So we have all of these advanced methods, techniques, and mechanisms that you need to remember, or that you need to at least understand. You don't need to remember them. Just know that they exist. So from time to time, you may need to use them. And probably the last thing that I would like to talk about today is how JavaScript actually works. So it actually works the same as any other programming language, but I want you to have a look at this presentation. So one moment, please. So this is how JavaScript works. So in our whenever we call or whenever we execute, let's say, a variable or any line of code, we simply putting it in what we call a memory heap. Okay, so for example, if we say let a to be 2, we're saving this a as a variable in our memory. Okay, let's say in this blue box, and then let's say whenever we call a function and it results in a value, okay, and we're going to save this value also in the memory, okay, but every time we call those functions or call those operators, we're actually putting them in the in that what we call stack, okay. So call stack works the following, okay, so it's basically a very long queue of different operations that we do in a JavaScript. Okay, and let's have a look. Let's imagine that we have 4 functions. Okay, function A, B, C, and D, and how they are executed. Okay, the way you execute it in your code, for example, if your A is on the top, okay, so the first line of your code is actually execution of A, so you place it here, okay, on your in your call stack. Okay, oh sorry, you place it here in your call stack, and there is only one function executed at this moment, and then you execute B, and then you could execute C and D. So what happens is that every time you execute a new function, it arrives in your call stack, okay, and your A from bottom part, it puts on the top, because what happens is that first we had only A here, and then B arrived, so A moved to the second part, or to the second, it moved to the top, let's say, okay, and then C arrived, so it pushed a little bit our stack a little bit up again, and then D arrived, it pushed once again our stack a little bit on top. So that's what we have at the end. If we have our 4 functions running, okay, so the first function that is going to run is going to be A on top of your call stack, and then B, and then C, and then D. Okay, and all of them are actually run from your memory heap. Okay, so it first comes to your memory, and then it's going to be executed in the call stack, and the result is going to be saved back again in your memory. Okay, so that's what you need to remember, as simply as it is. So every time we save something, we are saving it in the memory heap. Every time we execute something, is going to be executed in the call stack. Okay, and calls memory probably it stays until we shut it down, or we close our application or something. Call stack works is that it comes and it goes. So only the execution part of your code is present in the call stack, but if you save something, for example, the result of this execution is going to be saved in your memory heap. That's simply as it is. Okay, and JavaScript is a single-threaded language that can be non-blocking. Okay, so every time you execute a function, is going to be executed in order. So you won't execute A and B at the same time. First you execute A here, and then it goes. Okay, so B becomes the priority for your engine, and then engine executes B, and then when it's done, it goes away, and then C is going to be executed, and so on and so forth. So it's a single-threaded language that has a non-blocking attitude, or that has a non-blocking behavior, let's say. Okay, and that's how JavaScript works, and probably that's all you have to remember. Okay, and the last thing for today that I want you to do, I want you to go to google.com and write npm. And let me tell you what is npm. npm is npm was developed for developers to share their code. Okay, so this way any developer around the world can grab somebody else's code and use it in his application. Okay, this creates a kind of a great knowledge base of scripts that people can constantly update or improve and build application on top of it. Okay, and as a matter of fact, it's very rare that website or web application these days are built purely from scratch. Okay, so by using collective intelligence, we can grab pieces of code that are really good and build on top of it to create our own product. Okay, so let's say if you would need to implement cart validation in a JavaScript. Well, instead of writing it on your own, you simply can go to npm registry, and you can look for a cart validation script, which is actually probably is going to be available. Okay, all you have to remember is that some of the scripts may be malicious. So sometimes those scripts have to be validated and verified by NPM itself. Okay, so they look for this one, because what happens sometimes people don't know and they install some scripts that actually, when they run it in their application, it stores information of its users, personal information, and so on. So it's kind of a security issues problem. But most of the NPM scripts are fine. They're totally good and they can be used. For example, let me show you what we can do with NPM. I hope you can see. So if we go to NPM in Google, it says npmjs.com. So NPM is a package manager for the JavaScript programming language maintained by NPM Incorporated. Okay, and let's have a look. And we can look for any package we want. So for example, I'm looking for card validator. Okay, what it says is that a credit card validator provides validation utilities for credit cards data inputs. It's designed as a common JS module for use in Node.js, IO.js, or in the browser. It includes first-class support for potential validity, so you can use it to present appropriate UI to your user as their input. So basically, it allows us to create those validation fields or forms where users can input their data and their credit card data. And you can see it's a very popular package. Okay, so it's still updated and it's still supported by its developers. Okay, and it's not very heavy. There are totally 56 files, and it is licensed by MIT. So there is a download explanation, examples, and APIs, how you can use it. So you can see it supports UnionPay, it supports MasterCard, American Express, and other things as well. And all you have to do is to download it with npm install card validator. So to install npm itself, you have to probably go to npm install sorry, you just need to write npm install in your search engine, and no, how to install Node.js and npm on your Windows. Okay, so to install npm, you don't need to probably separately install it. Instead, you can it comes together with Node.js. Node.js is an open source cross-platform backend JavaScript runtime environment. And this is something that we are going to do on week number 9 and 10. So right now, all I want you to do is to go to nodejs.org, okay, and download it for your operating system. So in case if you have Windows, you just need to download LTS version, so long-term support version, not current, but LTS, okay? And it's also available for Mac and also available for a Linux operating system. So whatever you have, please don't go to nodejs.org and download it for your operating system and install it. The installation is very simple. You just simply install all the recommended properties and features. And your npm is going to come together with Node.js. So once again, you don't need to install it separately, just install Node.js for your computer. And if you have one, probably you need to update it, because sometimes Node.js is supported throughout the time. So it's a very advanced runtime environment for running your JavaScript backend. So it's being constantly updated. So probably you also need to update it as well. And yeah, I think that's all I wanted to tell you. So all you have to do is to install Node.js on your computer right now. NPM, we are going to do it later. I just wanted to introduce you to NPM. So just think of NPM as a registry or as a database of different packages that you can use for your own projects. Okay. What kind of packages? Well, it's up to you. You can use for card validators. You can use for anything you want. Okay. Well, I think that's it. That's all I wanted to tell you regarding JavaScript and our further actions. Now, let me quickly tell you a little bit about your assignment. So I'm going to open your assignment. Assignment number 4. So once again, in this assignment, yeah, you probably will keep your calculator as it is, but there will be significant changes in your code. Okay. First of all, we will expect, or I will expect to see the use of ES6 syntax, so const, let, arrow functions, template strings. What else? Let me see what else. Logical operators, function compositions, for loops, for each loops, and so on. Okay, so I added a little bit of explanation of each point. So all you have to do is to create a function calculate by using arrows. Once again, ES arrow function declaration. Inside of your function, you have to declare a variable name with let keyword. You will need it later when you will create a JavaScript object. Okay, and most of you actually haven't created JavaScript objects for their first assignment, but I wanted to see it. So and this time I explain a little bit more about assignment and what exactly I want to see. And declare a variable price with let. The value must get from the input starting bit. Okay, and the starting bit is going to. And I will fix it a little bit. So most of you actually already implemented it. Most of you kept it as $100. But for this assignment, the input value or the starting bit is going to be an input form. So you, that person who is going to use your calculator is going to decide how much is going to be starting bit. So it's not going to be 100 by default. It's going to be something else that you decide. Okay. So I will fix this part. Okay. And then you just have all the explanation here. Your calculator must work only if the name is not empty and price is not empty. So there will be a name of your groom or of your bride, okay? And there will be a lot of different options, okay, that I will add. So probably I forgot to modify something here, okay? Anyway, this part will remain the same for you. And there are a lot of things that I would like to see from you. So array for each method, array reduce method, const and let, conditional, logical operators, function compositions. Okay, so remember F, G, and X, ES template strings, ES arrow functions, objects, and for loop. Okay, and this time the evaluation will be even more on based on your JavaScript performance. Okay, so if your calculator doesn't work at all, so please do not expect high marks for this one. Okay, and for your sake submission, you must submit 2 links once again. One is going to be a repository link, and the second is the website link itself. So once again, you will need to post it on GitHub. And I will modify this part a little bit so it will satisfy all the explanation points that I have here. And do you have any questions maybe related to your assignment number 3 or assignment number 4? Oh, by the way, let's make the deadline more. Let's make it Tuesday midnight instead of Monday. Okay, so because you always ask me to extend it for one more day, so let's set it from the beginning. So I allow submissions from now, but the due date will be what will be it? Second of November, 29:59. Okay, so it's let's set it like this. Okay, and I expect the online text submission, not your files. Okay, and yes, and let me make it available for you so you can all see. And there are some examples for each filter reduce, template strings, for loop that I would like to share with you as well. So I'm also going to make it available for you so you can see. So you can download it. Inside you will find 4 different files with code. Inside of this code, you can find how you can implement for each, how you can implement filter reduce, how you can implement template strings and for loop and so on. Okay. And thank you all for joining today, and have a good weekend. And I think that's all.